In a world where food waste and unsustainable agriculture practices persist, millions of farmers struggle to sell their produce, while consumers seek fresh, locally sourced ingredients. Introducing the Green Harvest, a web-based platform that connects local farmers, businesses, and consumers to promote sustainable agriculture and reduce food waste. Well, just a little background of our website. Green Harvest is built to support the social enterprise of Rural Rising Philippines, or the RURI, which helps small-scale farmers distribute their crops. Aligned with the United Nations Sustainable Development Goal, or specifically the SDG 12, our system promotes responsible consumption and productions. This ensures the sustainable and fair food distribution for all. To ensure the effectiveness of Green Harvest, we analyzed several studies related to sustainable agriculture and food distribution. So here are the review of the related literature of our website. The first one is the Gabonada and Rolla of 2005 article, highlighted here that farmers' knowledge and adoption of sustainable land use management are crucial for long-term agricultural success. Well, Green Harvest integrates educational resources to support farmers in adopting a sustainable farming practices. So the second one is the Lopez, Mendoza, and Henyo article of 2008, emphasize the importance of technology-driven solutions for improving agricultural sustainable in the Philippines. Well, our platform leverages technology to bridge the gap between farmers and the consumers. Well, the third one here is the Mopper article of 2016 that identified the food loss and the supply chain as a major issue in the Philippine agriculture. While Green Harvest help address this by providing a direct-to-customer sales model, reducing food waste, and ensuring fair pricing. So the fourth one here is the Rovilos and Corpus article of 2023, studied how traditional and innovative farming method can coexist to sustain agricultural heritage. Well, Green Harvest values both modern agricultural technology and indigenous farming knowledge in supporting Filipino farmers. So the last one here is the Suaze article of 2019 that examines how sustainable agribusiness models impact environmental and economic growth. While Green Harvest aligns with this by promoting local produce, minimizing carbon footprints, and empowering farmers financially.
A well-defined methodology is important for ensuring a project's success. It provides clear phases for development, minimizes risk and improves efficiency, ensures consistency in implementation, and helps the team adapt and iterate as needed. For Green Harvest, the team adopted the SDLC approach as our main methodology. During the planning phase, we laid the foundation for Green Harvest. Small farmers struggle to reach the market, which causes unfair pricing, and food waste is the main problem that Green Harvest aims to solve in alignment with the Sustainable Development Goal number 12 through RURI. With this, we identify the stakeholders, the farmers, consumers, and the marketplace admins, including RURI. To proceed with the project development, we decided to use Angular to complete the front end, Node.js to develop the back end, and Microsoft SQL Server as the host of our database. In the analysis phase, we translated our vision into specific requirements. In alignment with our stakeholders, we identified 3 user roles: the admin, store owner, and customer. We defined core system functionalities, which include product listing, order management, and secure payment processing. In addition, we created a system wireframe to have an initial look and feel on Green Harvest. In the development phase, the actual coding happens. Node.js allows us to handle multiple client requests efficiently because of its non-blocking architecture, making it a great choice for web applications. Express.js, a lightweight framework, helps us structure our API effectively. Instead of writing SQL queries, we are using SQLize, an object relational mapper or ORM, for Node.js. This allows us to interact with our database using JavaScript, making our code more maintainable and reducing the chances of SQL injection attacks. We chose Microsoft SQL Server or MS SQL as our relational database. Since our system relies on structured data, an SQL database ensures data integrity and complex relationships. Our database is hosted on Azure SQL, which gives us scalability, backup management, and built-in security features. On the front end, we are using Angular, a TypeScript-based framework. Angular provides modularity, two-way data binding, and built-in security mechanisms, which makes it ideal for building complex web applications like GreenHarvest. For styling, we decided to use Tailwind CSS. Unlike traditional CSS frameworks like Bootstrap, Tailwind follows a utility-first approach which allows us to create highly customized and responsive designs without writing excessive custom CSS. Our frontend communicates with the backend via Angular services. These services handle HTTP requests, fetching and updating data in real time. This ensures that our UI remains dynamic and responsive to the user interactions. Here's an overview of our system architecture. The backend and database are hosted on Azure, while the frontend is deployed separately. Users interact with the system via Angular, which makes API calls to our Express.js backend. The backend then processes requests, interacts with the database, and returns responses to the frontend. We chose a modular backend approach rather than a full microservices architecture. This allows us to maintain separation of concerns while keeping development and deployment manageable. Our database follows a well-structured relational schema where tables like users, products, orders, and transactions are interconnected. This ensures data consistency and efficient querying. Security is critical in any web applications. We implemented JWT-based authentication to manage user sessions and role-based access control to ensure that only authorized users can perform actions. Before deployment, rigorous testing will be conducted to ensure system functionality and stability. We will conduct unit testing on backend APIs and Angular components, integration testing to validate interaction between the front-end, backend, and database, and security testing to protect against threats like SQL injection. Deployment involves moving the system from development to production environment for user access and usage. The backend and database will be hosted on Azure, and secure environment variables and API keys are configured. This will ensure that GreenHarvest is accessible and fully operational for users. Following the indicated phases, here's an overview of our project plan visualized through a Gantt chart. The planning, analysis, and design was conducted 2 weeks ago. Then we proceeded with the system development right away. Project setup was completed last week. The database that is hosted on Azure is now accessible through the backend, and the frontend is already set up for creation of application components. Currently, the team is working on creating API endpoints for CRUD operations. The API is documented using Swagger and is tested through Postman. For the following weeks, the team will focus on front-end development of the admin, customer, and store owner sides of the system. GreenHarvest is more than just a platform. It is a movement towards sustainable food distribution, empowered farmers, and responsible consumption. By using GreenHarvest, you are not only supporting local farmers, but also taking a step toward a more sustainable and waste-free future.